You should make it to rotate. Giving spin means you are rotating the body. You are giving some rotation motion to the body. Please, for God's sake, I'm scolding you, but you should have the minimum idea, sir. What do you mean by spin given? So you should, by this time, at this level of, by the time class 11, when you come, no, these technical words you should be aware. The body is given spin means you are giving it angular velocity. So you are going to give spin and also you are going to push it. Now, how to, first what we should do? We should predict the direction of friction acting. Whose help we should take? The point P. I'll take help of the point P. Now, what is the velocity of point P? V naught. V naught. And next, what we have is RO. How much it is? R omega naught. No, this is R omega naught by 2. We know what is the basic idea. V naught equal to R omega naught. No? So definitely V naught is greater than this. So how the resultant velocity will be? The resultant velocity will be directed towards right. Okay, let me take black color. Then how the friction should act? Backward. Is it a forward or backward slipping? Backwards, forward slipping it is. You are not going to look center of mass. You are not going to look at the center of mass. You are going to look at the point of contact. And then, what this friction does, it will retard and it will set up torque about point C. And finally, so what it does is it will increase the same idea like previous problem what we did. Here it will have velocity V1, angular velocity V1, omega 1. I'll come and check it. V1 will be like this, R omega 1, and still V1 greater than R omega 1. So therefore velocity of point P will be like this, and the friction will still be acting backward. So they show that it is a still forward slipping and V1 greater than R omega. Like this, what will happen? Center of mass will undergo retardation and this friction will set up a torque. This will continue. Finally, what happens at one instant, V will become equal to R omega. Then what is the velocity of point P? Will become 0. The same story here. I think you do any number of problems, the idea is same. This one, finish over. And velocity of point P is 0 now. Pure rolling. Look at now, it is forward slipping, it is that one. Both are, don't think that only the velocities are that one. Both angular velocity, linear velocity there. Will determine forward or backward slipping, the velocity of point P. Okay, after this, how to calculate this time? I'll apply conservation of angular momentum. Because this will be much easier. Initial angular momentum about axis passing through point P, which is perpendicular to plane, is equal to final angular momentum about this one. Why about point P only? Because normal reaction, weight and friction, they'll intersect axis of rotation, net torque is 0. So therefore, we can apply conservation of angular momentum. What is initial angular momentum? Due to translatory motion, mv naught r. Due to rotating motion, IC omega naught by 2. Both are clockwise. Agreed? About this point. This is R bar, this is V naught. Due to translating motion, it's a clockwise. due to rotating motion. But sir, you should write IP omega. I think go back to the definition. Angular momentum about point P or about a point on the ground is equal to what? Translating motion, angular momentum due to translating motion about center of mass plus angular momentum due to rotating motion about center of mass. I think that's what the definition says, not about the axis. This you should write. This should not be IP. This should be IC only. Sir, why the definition? Sir, why the definition came? We proved it. Finish over. No second thought on this. Finish over. So some students, I don't know what will happen. At the end of the chapter, they're asking, sir, why this is IC, why not IP? Because you're applying here. But what happened, the definition? And we proved it, no? The proof itself you are not accepting, then God only will help you. And now come for this, finally. Angular momentum due to translated motion of center of mass. MVR. Again, see, not IP omega, IC omega. So let's substitute all the values. V naught R. This is what? 2 by 5 mr square by
Sir, it's 2 by 3, sir.
allosphere, ma? Yeah, 2 by 3 mr square omega naught by 2 equal to MVR. This will be 2 by 5 mr square Now what to do LHS? We have both V0 and numerically V0 equal to R omega. But here what when the tangential to given is omega naught by 2. So I'll substitute things. You can see MR get cancels. V0 R omega naught by 3. V plus 2V by 5. What to do? R omega naught. Numerically, V0 is equal to R omega naught. But sir, like, is it not V0 equal to R omega naught by 2? No. So 4 V0. So what is finally V is equal to? V is equal to 20 V0 by 21.
Sir?
2 by 3. 2 by 3. 2 by 3. Please let me finish off. In the end, you can ask it because others. In the end, you can come for everything. This will be 5V by 3. How much we are getting? This 3. This is 5. I'll justify my answer. You have to look at this particular part. This R omega high rot V0. Agreed, all of you? Sir, what it is? There's a condition for pure rolling, no? But sir, it's a forward slipping. If it were pure rolling, what would happen? V0 equal to R omega naught. If it were pure rolling, V0 would have been equal to R omega naught. Since V0 is not equal to R omega naught, that's why what happened? It is having it's having a forward slipping. Means sir, can I apply S? There's no problem for that. Can we calculate time? I think it's quite easy. So now we know the way of the friction will retard acceleration of center of mass. So what is the time taken to attain pure rolling? Again, stick on to the basics here. What is the final velocity attained? V0 retardation of center of mass into T. What is the retardation of center of mass? Mu gt or F by m. Getting confusion? Go back. And what is V? V is 4 V0 by 5. And this is mu gt. So all this will get the time taken to attain pure rolling. If V0 equal to R omega naught by 2, then velocity of point P will be 0. Then practically what meant? There is a friction acting. I know there is a friction acting. So V0 is not equal to R omega naught. R omega naught by 2. If V0 equal to R omega naught by 2, then what meant? Velocity of point P will be 0. Then it immediately attain pure rolling the moment I release. But such a thing was not happening. So this shows that V naught is not equal to r omega naught by 2. And for if it were pure rolling, V naught would have been equal to r omega naught. That I'm replacing here. There's no concept, just general observation it is. Okay, now see, linear velocity given, angular velocity given, both are given. I can now, sir, I'll make 2 omega naught. Instead of giving omega naught by 2, I'll give this angular velocity 2 omega naught.